So what if you want to travel from point A to point B? And let's say this is your bahay. Tapos ito yung school. So from point A to point B, you decided to travel like this. And kung ano ito yung ruta mo papuntang A and B. So, what do you call this? I'll give you 3 seconds. So that is 1, 2 times up. That is your distance. So your distance is basically just the total area covered during your entire journey, kumbaga. So that is the concept behind your distance. So if that's the distance, then what do you call this? What do you call that straight path from A to B? Yung blue. So I'll give you 3 seconds again. 1, 2. Okay, so that is what you call your displacement. So if your distance is the total area covered during your journey, your displacement is the shortest path from A to B. So the shortest straight path rather from A to B. So basically, it doesn't account for the total area covered during your entire journey, but simply just the distance between the 2 points. Okay, so in this video, we will talk about displacement. So displacement again is just the shortest straight path from one point to another, and it's usually between 2 points A and B. So if you are familiar still with your trigonometry, it is simply analogous to the hypotenuse of your right triangle, because if you take a look at this, it will take longer for you to travel from A to B using this path compared to using this path towards using the hypotenuse. So displacement again is the shortest straight path. So if the hypotenuse is the shortest path from A to B in a right triangle, then it is simply analogous to your displacement. And this will be useful whenever we try to solve your vectors later on. So ayun lang, pahapyaw lang. So displacement is usually symbolized by your delta x. So your delta x is equal to your final distance or your final point minus subtracted to your initial point. So let's have this as an example. Suppose you have your x final at 30 meters at your x and your x initial at 10 meters. What will be your displacement? So your displacement will just be your final subtracted by initial. So that's 30 minus 10. That will give you 20 meters. So if you take a look at the graph here below, so this is how you would represent that. That's how you would represent your 20 meters. So from here to here, that is just the displacement. That is the shortest path. So that is your 20 meters. Okay. So you can take a different path here. So ganyan. So this will, wala. So that will be your distance. Okay. And this short path is your displacement. Okay. I hope I made that clear. So next one, say you want to go from point A, but then point A to point B. Mali. Point B and let's say the distance between the two, or kung yung gap nila between the two is ilan ba? 200 kilometers. And let's say let's say ikaw ay isang ultra burkis na na mayroong limousine. Hindi ko alam kung ganyan yung itsura ng limousine. Nalimutan ko. Or feel ko may umbok pa siya rito pag ganyan. Pag ganyan ata. Yan. Yan. Kunwari limousine na lang yan. So, kunwari, you want to travel from point A to point B. And during your entire trip, from point A to point B, it took you 3.5 hours to do so. So, I want to ask you, how how fast are you going, or how fast are you traveling from point A to point B? So, if you are familiar with this, you already know what to do. You're just gonna simply divide the total distance divided by the time it took for you to go from point A to point B. So that is just 57.14 kilometers per hour. So that is your that is the ganyan kakabilis pumunta from point A to point B. So what does this value represent? So that value represents your average velocity. So average velocity is just the velocity that it took your object to move from point A to point B without oh my god, sorry, without factoring fluctuations. So what do I mean by fluctuations? It can be your traffic, or it can be you slowing down, speeding up. So we will talk about that after this. No. So the velocity took the time to move from point A to point B without factoring fluctuations, such as your average velocity. Then it is usually expressed in meters per second. So what is the difference nga naman between speed and velocity? So your speed mainly talks about the magnitude or the value itself, while the magnitude or the value, while your direction talks about while your velocity talks about both the magnitude and direction. Okay? So your average speed, I think narinig nyo naman din to. I think yung sa mga triads, ganyan. Yun, ganyan. Di ba, speed is equal to distance. So, ganyan. Kung narinig nyo na yan or nakita na yan, I hope so. Because your average speed is just equal to distance traveled over time elapsed, or your speed is equal to distance over time. While your speed is talking about the distance, your velocity is talking about the displacement, meaning the shortest path from A to B, okay, over time elapsed. So this displacement is symbolized by delta x, so over t. So you can decompose that further into your final and initial components divided by t, okay. So if you plot your displacement as a function of time, you will get this graph. So this graph, let's say you want to find the velocity. This entire line, by the way, is your velocity. So let's say if you want to find the velocity at this point and this point, you can just take again, it is defined as displacement over time kanina. So displacement over time. So from here, or sige, tuturo natin. From here to here, so your final, assuming this is here, this is not assuming because it says here F. So this is your final. So that is XF subtracted by this, your initial, and initial X naught. Sorry. Ay, ano ba? Dapat red. X naught over yung time elapsed. So, yung time elapsed in this displacement time graphs. This is the time elapsed. So, basically, it is just your T final subtracted by your T initial. So, pag sinubtract mo tong dalawang to, you will get the time it took from here to here. Okay, so that will be your time elapsed. So, ganon. So, again, with that, you will know that your average velocity rather is just equal to the change in the displacement over the change in time. Ayan. Now, moving on. What if you decided that you want to take the average velocity at a very infinitesimal point at, let's say, di ba kanina, 2 points yung ganyan. So, you decided to shrink that, shrink that, shrink that, shrink that until you reach one single point along this line. Okay? So, that is what you call now your instantaneous velocity. So, your instantaneous velocity is just defined as the velocity at any moment at an infinitesimally short time interval. So, unlike average velocity, your instantaneous velocity factors in your speeding up, speeding down, or stopping, because it takes account the velocity at each point, no? At each point instead of the previously discussed na malaki yung points na kino-consider niya. So at your average, your instantaneous velocity takes account a very short uh, time interval, usually near zero. So basically, it calculates the velocity at that certain point. No. So I hope that is clear. So if your average or your average velocity is defined as the change in, or it's just the change in x over change in t, or displacement over change in time, your instantaneous velocity will be defined as the limit as the delta t approaches 0 of the function delta x over delta t. Again, why it naging limit? Because we are calculating the velocity as time reaches 0 at infinitesimally short amount of time. A short time interval. Well, infinitesimally short, or short time interval, usually near zero. Okay, so that's why it's the limit. So I want you to take note of this, and in any moment, the instantaneous speed is equal to the magnitude of your instantaneous velocity, because uh, the distance and displacement becomes the same at infinitesimally small point. So, sinasabi lang nito na kapag as you approach zero with time, your distance and displacement will be equal. So, again, another one is that if your object is moving constantly or uniformly, then the average velocity is equal to instantaneous velocity. So, when we say moving constantly, your graph is just a straight line. It's just a straight line. Ganyan. So, ano yung sabi ko? Average velocity and instantaneous velocity is equal to the same because wala naman siyang slope. Kumbaga, uniform yung slope nitong straight line compared dito sa curved line. Diba? So, that's why they are equal in your calculus class. Ayan. So, that is your velocity. So, okay, let's have this another example as well. Sorry. Let's say you are, again, moving from point A to point, parang ayoko talaga ng dilim niya. Yan. From point A to point B. Lagi na lang ganito. From point A to point B. And, ayan. This is your point A to point B. And this is your car. Ayan. This is your car. So, from here to here, no, you are moving at your velocity is equal to 15 kilometers per hour. So your velocity is equal to 15 kilometers per hour. Oh, sorry, nalaglag yung tablet. And at this point, at this point, say A1, ganyan. Point A1, you travel, you stop. No, you stop. And you stop. So, look at it. So, you entirely stop. So, that your velocity will be equal to 0 kilometers per hour. Then, pagdating naman dito sa point A2, uh, A2, your velocity increased to uh, 35 kilometers per hour until you reach the ending. So, in this act, what is happening with your car? It is changing velocities. It is changing velocities. It stops, it speeds up, it slows down, whatever. So that phenomenon, the slowing down or the speeding up or the change in the velocity your change in velocities is what you call your acceleration. So your acceleration is defined as when an object changes velocities. So whenever you try to slow down, to speed up, blah blah blah, stop, you are considered to be accelerating because some in like, di ba, in everyday lives, you think about accelerating as like speeding up because you're accelerating. But in physics, your acceleration is defined as just the changes in your velocity. So it doesn't matter if you slow down, speed up, or stop, you are considered to be accelerating. So it is usually how rapid the velocity changes. So let us talk about your average acceleration. So your average acceleration is just similar to your average velocity, wherein your average acceleration is defined as the change in velocity over time elapsed. So just it is just your delta v over t, or you can write that this way as your final velocity over initial velocity divided by time. So let's say you have this one. Given a car accelerating from rest, okay, you know that it's from rest. Rest means it starts from 0 meters per second to uh, a certain velocity v final meters per second in t seconds. What is the magnitude of the uh, what is the magnitude of the acceleration? So given that you're this one, given this one, so you know that your acceleration is equal to delta v over t. So using this one again, it's just your uh, final velocity subtracted to your initial velocity, which is just 0 meters per second over t seconds. You will get this v final over t seconds. The meters per second, right? Over seconds. So, tama naman. So, the unit will be, or the acceleration will be vf meters per second times t seconds, or just vf meters per second squared. So your unit for acceleration is vf. Your unit for acceleration is usually expressed as meters per second squared. Di ba kanina sa velocity is just meters per second? Your acceleration is defined or is expressed as in meters per second squared. Okay. That is one example. So if you plot your acceleration in a velocity, if you plot your velocity as a function of time, you will get this graph. And if you want to find the acceleration from this point to this point, you will have to subtract your initial velocity, your final velocity, your initial velocity, and divide that by your final velocity over initial velocity. So you can just express it as like this. So just subtract the two divided by subtracting the two again, then you will get that acceleration is basically just the change in velocity over the change in time. Okay. So again, if you take the limit, or if you want to take the acceleration at a certain point, you just have to take the limit of that this function. Again, similar to your instantaneous velocity, so that will be called now your instantaneous acceleration. It's just the acceleration at a certain infinitesimal point. So given that this is your acceleration function, if you take the limit as t approaches 0, you will get your instantaneous acceleration at that point. Okay, so conceptuals, let us ask this. If your velocity is equal to 0, is your acceleration equal to 0 as well? And if your acceleration is equal to 0, is velocity equal to 0? So the answer for this is no. So number 1, or sa letter A. Why is it no? So if sorry, napindot ko. So, okay. During, let's say, may binato ka sa taas, di ba? So, from here, you threw a ball up high. So, this is a concept of your projectile motion, which will be tackled in the future video. So, from this, you threw a ball from here to here like this. Then, at its peak, we know, or at least I hope you know, during your high school physics, that your velocity uh, at the peak of your projectile, your velocity is equal to 0. Yeah, 0. While the acceleration is not equal to 0 because gravity is acting on it downwards at negative 9.8 meters per second squared. So even if the velocity is 0, there are instances also that your acceleration will not be equal to 0. An example of this is this one. So this is an example for letter A. So letter B, if the acceleration is 0, is velocity already equal to 0? The answer for this again is no. Because why? Because we defined acceleration earlier as the change in velocity. So if there are no changes in velocity, meaning there will be no, sorry. So wait no. Okay. So again, we defined acceleration. We defined acceleration as the change in velocity. So if there are no changes in velocity, meaning there will be no acceleration. So what does this mean? So what does this mean? So this means that your object, meaning that it doesn't change and its velocity doesn't change, meaning that your object is just traveling at a constant velocity. So your velocity is equal to a constant value. It is not changing, therefore it has no acceleration. Oh, sabi natin your acceleration is 0, it doesn't automatically mean that your velocity will be equal to 0. Okay, so I think that's all. Okay, so sige, hupain mo na lang. You may fast forward a bit na lang. Okay. So, anyways, let's say that you are this car, right? You are traveling again from point A to point B, and with your car, sorry, medyo lousy na yung car. Okay, sorry. From point A to point B, at this point A, sige, kakat ko muna para hindi na ako kailangan mag-drawing. From point A, here, you are traveling at point A1, you are traveling at is equal to 20 meters per second. Then sa AB naman, ay sa A2 naman, you are traveling at 15 meters per second. And pagdating mo naman sa A3, okay, you are traveling now at 5 meters per second. So, in this action, what is happening with your pagpalain tayo ng Diyos, mga kaibigan. What is happening with your velocity? It is decreasing. Therefore, you are decelerating. Okay? So this is the concept of deceleration. So deceleration is deceleration is when an object is it is slowing down. Oh, mali na yung grammar ko. So deceleration is happening when an object is slowing down, but it doesn't imply that deceleration is always negative. So why is it that case? So let's say you are traveling right, okay, you are traveling this, so this is your Cartesian thing. So this is yeah, your car is going this way, your velocity is towards this way, and you are decelerating, so meaning you are going, your acceleration is towards the negative. So in this instance, your acceleration will be negative because you are slowing down. Basically, you are slowing, and your vector for acceleration is pointing the other side. If you are traveling, if you're traveling if you are traveling towards this way, so this is your velocity. But acceleration. So this is your velocity pointing towards the left. So you're traveling left, and you're also decelerating. So your acceleration will be towards this way. So meaning that both of your vectors are negative. So your deceleration here is equal to positive rather. And for this one, your deceleration is equal to negative. Okay? So I hope that is clear. And if the acceleration and velocity points in opposite directions, the object is decelerating. Okay? Or not really. Tama naman. If A and B points in the same opposite directions, the object is decelerating. And that's not really the case, but most of the case that also applies. And also, this object is also decelerating. Ano, maliktad. Ano ba? Ayan. Hindi, tama naman. Your acceleration is pointing the negative side, so you are decelerating. So your deceleration will be positive. Okay? So, again, assuming that your acceleration now is constant, it means now that your velocity time graph will be a straight line. So I want you to know that the area under this straight line, or the area under this straight line, is your displacement. Okay, so that is your displacement. And in motions at constant acceleration, you have these four kinematic formulas. I won't go in depth with this with the derivations for this equations, but I want you to know that during a constant acceleration of an object, if you are trying to find the velocity of an object, you can use number one. Okay, if you are finding the velocity, given that you have your initial velocity, you have your constant acceleration, and you have your time, you can use number one. So for number two, if you want to find the displacement, this is displacement, initial delta x. If you want to find the displacement, given that you have your initial position, you have your initial velocity, you have your time, you have your constant acceleration, and you have again your time. So you can use number two. And if you have number three, if you are trying to find the velocity again, pero wala kang time, you only have your acceleration and your displacement. This is displacement delta x, diba? So you can use number three, and your number four is just defined as four is just defined as the average velocity. So that is your four kinematic equations, and we will use that to solve problems in the future videos. So that's all for this video. So I hope you learned something, and see you next time. Bye bye.